At this moment, 780 million kilometers from Earth, outside Jupiter's orbit, an icy moon with a diameter of 480 kilometers is plunging inward at a speed of 110,000 kilometers per hour. It has no name, only a cold number, 2023 XL1. In 72 hours, it will reach an invisible boundary, then be torn into trillions of fragments in an instant, becoming the brightest bloodstain in Jupiter's rings. Do you think this is a cosmic accident? No, this is an execution written into the laws of physics, the Roche limit, the cosmic scalpel used to dissect celestial bodies, no exceptions, no mercy. We are used to imagining the universe as a gentle starry canvas, and planets and moons as stable drifters, but the truth is that the universe is full of invisible red lines of death, and the Roche limit is the deadliest one. It is not a distant theory, nor a formula game written by scientists, but a cosmic tragedy that is happening and has happened countless times. The question is not will it happen, but when it happens, can we understand this cruel dissection process? What's more terrifying is that the Earth we depend on for survival has been on the verge of this red line of death twice, but we never noticed. First question, what exactly is the Roche limit? Don't rush to open the textbook, and don't try to muddle through with vague words like gravitational difference. Let's start with the simplest analogy. Stretch out your arm, hold an egg upward with your palm, and pull upward on the top of the egg with your other hand. When the pulling force is less than the bearing capacity of the eggshell, the egg is safe and sound, but when the pulling force exceeds the critical value, the egg will break instantly. The essence of the Roche limit is such a gravitational tug-of-war. The two sides of the contest are not your two hands, but the gravity of the planet and the gravity of the moon itself, and the egg is the celestial body that tries to cross the red line. More precisely, the Roche limit is a critical distance, when a small celestial body approaches a large celestial body within this distance. The gravitational difference between the near and far ends of the small celestial body by the large celestial body will exceed the gravitational cohesion of the small celestial body itself. This gravitational difference will directly tear the small celestial body apart, and this distance is not a fixed value. It depends on the density ratio of the two celestial bodies, their structural strength, and the rotation speed of the small celestial body, but the core logic has never changed. If the gravitational difference is greater than the self-cohesion, it will disintegrate. If it is smaller, it will survive. It's that simple, simple to the point of cruelty. Wait, there is a trap that is most easily overlooked. The Roche limit does not mean breaking only when hitting, but breaking when approaching. Many people mistakenly believe that the disintegration of a celestial body is due to a physical collision with a large celestial body, just like a car hitting a wall. But the horror of the Roche limit is that it does not require collision or contact. As long as it crosses that invisible line, gravity itself will become a weapon to tear the celestial body apart. It's like a person being thrown into the deep sea. They don't drown in the seawater, but their internal organs are directly crushed by the water pressure. Death comes from internal collapse, not external impact. Why is this? We speak with data, no empty words. Take Jupiter and its moons as an example. Jupiter's mass is 318 times that of Earth, and its gravitational acceleration is 2.5 times that of Earth. Suppose a moon with a density equivalent to that of the moon, 3.34 grams per cubic centimeter, approaches Jupiter. The gravity of Jupiter on the near end of the moon will be about 1.8 times greater than that on the far end. When this gravitational difference reaches 1.2 times the moon's own gravity, the core of the moon will start to disintegrate. First, the rocks and ice on the surface will fall off, then the silicate shell of the core will crack. Finally, the entire moon will be pulled into a long, thin stream of matter, which will either fall into the large celestial body or form a ring surrounding it. Here is a set of more intuitive data, no abstract formulas, only the impact you can feel. For a celestial body 100,000 kilometers from Jupiter's surface, Jupiter's gravity at the near end is 27.8 meters per square second, and at the far end is 25.1 meters per square second. This 0.7 meters per square second gravitational difference seems insignificant, but if placed on a satellite with a diameter of 500 kilometers, It is equivalent to exerting a pulling force of 11,000 tons per square meter on both ends of the satellite. This pulling force is enough to pull the hardest diamond on Earth into powder. You read that right, it's diamond, not reinforced concrete, not rock, but the hardest natural substance in the universe. Worse, the Roche limit has two execution methods. One is gentle, relatively speaking, and the other is extremely cruel. The first is gradual disintegration, which applies to loosely structured celestial bodies such as comets and icy moons. These celestial bodies have weak self-cohesion. When they approach the Roche limit, they will not break instantly, but first peel off material from the surface to form a long comet tail or material flow, then gradually disintegrate. The entire process of this gradual disintegration can last for days or even weeks, just like a terminally ill person whose body gradually declines and finally passes away. The second is catastrophic disintegration, which applies to hard, rocky satellites or asteroids. These celestial bodies have strong self-cohesion. When they cross the Roche limit, the gravitational difference will instantly exceed their structural bearing capacity. The entire rocky celestial body will disintegrate in milliseconds, from a complete sphere to countless fragments of varying sizes, with no transition or buffer in between, just like a detonated bomb, intact 1 second and annihilated the next. In 2009, an asteroid with a diameter of about 50 kilometers collided with Jupiter, which was such a catastrophic disintegration. The energy generated by that collision was equivalent to 10 trillion tons of TNT explosives, 300 times the total energy of all nuclear bombs detonated on Earth. Let's go back to the icy moon 2023 XL1 mentioned at the beginning. According to observations from the Hubble Space Telescope, its density is 1.9 grams per cubic centimeter, mainly composed of ice and rock, with a rotation period of 8.3 hours. Through calculation, Jupiter's Roche limit for it is 171,000 kilometers. That is to say, when it is less than 171,000 kilometers from Jupiter's center, it will start to disintegrate. At this moment, its distance is less than 180,000 kilometers, approaching the red line of death at a speed of 110,000 kilometers per hour. For every 1,000 kilometers it approaches, about 1 billion tons of ice will peel off its surface. These peeled ice layers will form an ice dust belt hundreds of thousands of kilometers long, shining like a silver ribbon leading to hell under sunlight. You may ask, if the Roche limit is so terrifying, why hasn't our moon been torn apart by Earth? What exactly is Earth's Roche limit for the moon? The answer is actually very simple. The moon is now about 384,000 kilometers away from Earth, and Earth's Roche limit for the moon is 9,500 kilometers. That is to say, as long as the moon does not approach Earth within 9,500 kilometers, it will not be torn apart. But here is a chilling fact. The moon is moving away from Earth at a speed of 3.8 centimeters per year, and when it was just formed 4.5 billion years ago, it was only 23,000 kilometers away from Earth. At that time, the moon was only 23,000 kilometers away from Earth, farther than Earth's Roche limit, 9,500 kilometers, but already very close. At that time, the mountains on the moon's surface were pulled to more than 10 kilometers high by the gravitational difference of Earth, and the entire moon was shaking violently, on the verge of disintegration at any time. It can be said that the moon's survival to this day is just a fluke. What's more terrifying is that Earth has been on the verge of the Roche limit twice. The first time was 65 million years ago, when an asteroid with a diameter of 10 kilometers collided with Earth, triggering the extinction of dinosaurs. But few people know that before colliding with Earth, this asteroid first approached Jupiter, was accelerated by Jupiter's gravitational slingshot, and then flew towards Earth. When this asteroid approached Earth to about 100,000 kilometers, it had entered Earth's danger zone, only about 5,000 kilometers away from the Roche limit. At that time, its surface had already started to peel off, forming a long dust belt. If it had approached a little closer, it would have been torn apart by Earth, turning into countless fragments hitting Earth. In that case, Earth might have been shattered into pieces, not just the extinction of dinosaurs. The second time was about 10,000 years ago, when a comet with a diameter of about 100 kilometers approached Earth to about 120,000 kilometers due to orbital deviation, only about 25,000 kilometers away from Earth's Roche limit. At that time, the nucleus of this comet had already started to disintegrate, and the resulting dust and ice particles entered Earth's atmosphere, forming a meteor shower that lasted for weeks, and even triggered global cooling. Fortunately, this comet did not cross the Roche limit in the end. Instead, after approaching Earth, it was slung to the edge of the solar system by Earth's gravitational slingshot. Otherwise, humans might never have been born. Seeing this, you may feel a sense of nihilism, since the universe is full of such death traps, and since our Earth and Moon only survived by fluke, what is the meaning of human existence? We rush about for life every day, strive for our dreams, and get entangled in love and hatred, but in the face of the Roche limit and the gravitational laws of the universe, we are no different from a grain of dust or a fragment. The universe doesn't care about your calculus, your promotion and salary increase, or your joys and sorrows. It doesn't even bother to record your existence, let alone show mercy because of your fragility. But this is not a reason for despair. On the contrary, it is precisely the meaning of our existence. The Roche limit is cruel, it tears apart celestial bodies and destroys everything, but it is also fair, it does not favor any celestial body, nor pity any life form. It only follows the laws of physics, cold and firm. As humans, the only known life form in the universe that can understand the Roche limit, observe cosmic tragedies, and think about our own existence, our meaning lies in creating our own warmth and light in this cruel universe. We will observe the falling icy moon with telescopes and calculate its disintegration time with computers. We will record this cosmic tragedy with words and images, not to witness destruction, but to understand the universe and cherish everything we have. Because we know that the reason why Earth can rotate steadily and the moon can accompany quietly is not because the universe is gentle, but because we are lucky enough and small enough. We are so small that the universe has not noticed us for the time being, so small that we have the opportunity to love, struggle, and grow in this cruel world. Just like the icy moon that is disintegrating, although it will be torn into trillions of fragments, its matter will not disappear. They will become part of Jupiter's rings and drift in the universe. Perhaps billions of years later, these fragments will be attracted by a new celestial body, become part of it, and nurture new life. Destruction is not the end, but the beginning of a new life. While the universe tears everything apart, it also creates everything. This is the balance of the universe, cruel yet poetic. In 72 hours, that icy moon will reach the Roche limit, be torn into fragments in an instant, and become the brightest bloodstain in Jupiter's rings. And we will look up at the sky, glance at the distant Jupiter, then lower our heads and continue our lives, going to work, eating, accompanying our families, chasing our dreams.